Hello, welcome to our video on object-oriented design. Today we are going to start a new playlist and also it is of 8 to 9 part series around object-oriented design and analysis. Uh, Obviously, object-oriented design is one of the fundamental and foundational concepts in any software tech industry, basically in the software development role, senior staff role. So you are always, almost always expected to receive one or two questions on software on object oriented design. So we are going to cover those overall at a holistic picture, and today we are going to start with classes and objects. So let's jump straight in. So object oriented design, let's start with the history. I think this is very important to understand why object oriented programming is important today, right? So programming is basically giving certain instructions to the computer, right? So at the beginning of the computer era, the programming was usually limited to machine language programming, right? Now, machine language means those sets of instructions like that are very specific to a particular machine or processors, which are in the form of zeros or ones, like bits, right? It's actually impossible to develop any software used in today's scenario with just a sequence of bits. You can understand the kind of large scale applications that are out there. This was the main reason why programmers moved to the next generation of programming languages, where they developed the assembly language, right? Which were very near to the English language, so it was very easy to understand, right? Assembly languages were used primarily in the microprocessors. So with the invention of the microprocessor, assembly languages basically flourished and they ruled the industry for a certain number of time. But that was not enough. Again, programmers came up with something new, and that is where they created structural programming, right? And then they followed with procedural programming. The basic principle of the structured programming approach is to divide a program into functions and modules, right? The use of modules and functions makes the program more understandable and readable, right? It helps to write cleaner code and to maintain control over the functions, methods, modules that you are writing. So it primarily focuses on the development of large software applications, like for example, C is a structured language, uh, and modern operating systems were developed using that. The programming languages like Pascal also follow this approach, right? Procedural programming approach is also known as the top-down approach, right? Right. In this approach, a program is divided into functions that perform specific tasks, right? So this approach is mainly used for medium-sized application where the data is basically global, right? And all the functions can access the global data. So it is a stateful programming language and the data is maintained globally. Main drawback of the procedural programming approach is that the data is not secured because obviously data is global and can be accessed from any function, right? So basically the program control flow is achieved through function calls and go to statements, right? In that way, uh, there are several programming languages that follow this pattern, like for example Fortran, COBOL, right? You must have heard about those. They follow the procedural programming language, the pattern, right? But there were obviously still issues, though they fulfilled the criteria of well structured programs, softwares, applications, but they still did not meet the requirements like as the requirements grew over time, right? Because they seem to be very over generalized and don't relate much with real time applications, right? So to solve such kind of problems, object oriented programming and object oriented approach was developed as a solution, right? So this is how object oriented programming came into the picture, and today almost any application that you can think of, most of the cases, maybe not compilers, maybe not operating systems, but even I think operating systems like device drivers and all also use C++. But most of the applications, and at least consumer facing applications, all of them use or at least try to use some origin of object oriented programming. So which is why this skill and this knowledge is very important today, right? Now let's take a look at how the object oriented programming evolved. Now we have talked about how the object oriented structure evolved. Well, what are the programming languages that? So basically in the 1960s, the first thing that came out was Simula, right? It was first introduced, the object-oriented concept was first introduced in this programming language. It was developed in the 1960s. Simula basically introduced the concept of classes and objects and provided the the foundation for the modern object-oriented programming languages. Right. Next came Smalltalk in 1970s. Smalltalk was developed by a team in Xerox in the 1970s, which was so-called the true object-oriented programming language, the first true object-oriented programming language, because it introduced the concept of message passing and dynamic binding, right? Which basically allowed objects to interact with one another in a very flexible way, right? The next that came up, and I think a lot of you are familiar with this, is C++. Came in the 1980s. C++ is still used in the mainstream development today. It added the object-oriented feature to the popular programming language C, right? Which also included a much more object-oriented concepts, like for example, like classes and objects were already there, plus they also introduced inheritance, right? So C++ became very popular. And then in the 1990s came Java. Java is so-called one of the most popular programming languages. It was developed by James Gosling and his team at Sun Microsystems in the 1990s. And it was designed to be, simpler, safer, and more portable version of C++. It introduced the concept of platform independence, so allowing Java code to run on any computer that had a Java virtual machine installed. So that helped in the adoption of Java as one of the primary programming languages to build applications. Right? And then there are many other applications and which have been developed by individual companies. Like for example, the next in the 2000s came .NET, which was developed by Microsoft in the early 2000s. It introduced a new way of developing object-oriented software. It introduced a common concept of CLRs, right, like common language runtime, which allowed developers to write code in multiple programming languages and have them all run on the same platform, right? So basically, if you think about modern object-oriented programming languages, there are several programming languages which follow, almost all of them follow some form of object-oriented design, right? And various new concepts have and techniques have evolved. Many design principles have evolved, like for example, solid and domain-driven design. I've discussed this in one of my earlier videos. Please do take a look at those. But basically, that is how the object-oriented programming languages evolved over time, right? So now let's jump into what is object-oriented programming, right? So a programming paradigm that focuses on the creation of objects that interact with one another to solve a problem, right? So basically, it emphasizes on the concept of objects, classes, and primarily there are few concepts around object oriented programming, like for example, inheritance, encapsulation, polymorphism, abstraction, right? These are whenever you are following an object oriented programming language or object oriented design, these are certain concepts that really help, right, to design your system. It is the way object oriented programming languages are designed, or applications are designed, that it enforces that you have these kind of contracts and mechanisms in place so that you cannot go wrong by design, right? So now we will focus on the object-oriented programming using the programming language Java, but it is all very similar in almost all the programming languages. Primarily syntactical changes. There are some semantic changes also, but it is very easy if you just learn one of the programming languages. And Java is, as of today, Java, Python are the most popular object-oriented programming languages still. So now let's jump into what is a class, right? The first thing that you should know when you are doing in a object-oriented programming or learning about that is a class, right? Class is basically a blueprint or a template for creating objects, right? That is not an object. It is just the blueprint of or the contract, right, for creating objects. Basically defines the properties and the behaviors that an object will have, but it itself doesn't actually create the object, right? So if you take an example, so this is a person class. If you see this class, this is basically a blueprint of a class called person, right? This class, firstly, this is where we are defining the class. The person is the name of the class, right? Now the person has two properties, a name and age, right? uh, I will again say that we are discussing in Java. So basic familiarity with Java is, I am hoping it is required, but still I'll try to explain the concepts as we go along so that it will be easier. So these are the properties of the person that we are defining, right? The person class. The next is the constructor. Constructor takes two arguments. These are all argument constructor. For example, this is taking both the name and the age and sets the corresponding properties, right? So that is the constructor. And then these methods are called accessors and modifiers, right? Basically, this is where you encapsulate. You are not directly giving access to the properties. So if you notice, name and age, they are private, so those can't be directly accessed. If you have to access, like if you have to get or set, right, mutate the values of these properties, you have to use these accessors and modifier methods, right? So that is what a class is. Next, let's define what is an object, right? An object is an instance of a class, right? It is the actual thing that we are creating, right? So if we take an example, we have created a class in the last slide called person. Now, if you have to create a person object, let's see how will that look like. So this is a very basic Java main method where the class name is main and we have provided a main function. And if you notice, the first line inside the main method is an object. So we are creating a person object using the new person. Basically, the new person is, we are invoking the constructor that we have defined, and we are giving inputs as the name and the age. Basically, this is creating an instance of the person class, right? Now, the person variable, if you see in this line, is now initiated with this object, which is the person whose name is Alice and age is 25. And then we are printing those two methods using the accessors and modifiers. So the first thing that we are printing is the name, and the second thing is the age. How we are doing that? We are using the getters, that is the accessors. So, and if you run this program, the output that will come is name colon Alice, age colon 25, because person dot get name is giving Alice and person dot get age is giving 25, which we have set in the first statement of this method, right? Now, I would like to turn your attention towards how you should think about whenever you are giving an object-oriented design question or something like that. I mean, there is a mental model that really helps whenever you are giving interviews. So let's look at that. How does the object-oriented analysis and design primarily looks at? So if you are asked a question, obviously you will gather the requirements, you will understand and analyze the requirements. And basically, if it is an object-oriented analysis like OD or OAD question, the first thing that you should do is you should identify the objects in that question, right? So if there is a question that is asked, the first thing that we should identify is what are the core objects, right? Basically, what are the classes and where do we use those classes to create instances of objects, right? So you have to identify that first. Once you identify that, the next thing is you define the contracts. So for example, if we have identified, okay, there will be a person kind of a object, right? The contract is basically the class, right? So you basically go back and understand, okay, this is the object, person is the object that we need, and for this problem we'll need person to have a name and an age. Okay, so now our contract should be a person class with the name and age as properties, constructor and accessors and modifiers, right? So you define the contract, and then once that is done, you will establish the relationships between all these objects, right? That is basically your design. It's very simple. There is nothing to complicate here. You are asked a question, you identify the objects. Once you identify the objects based on the question, you define the contract, which is the classes. And when all these objects are defined and the classes are defined, you basically have to write probably some kind of a main logic or a business logic where these objects are going to interact with each other and they have to establish some kind of a relationship. If that part is clear, then your problem's solution will come up easily, right? So this is the starting point of object oriented design. Hopefully this was useful. Thanks for watching.